Okay, welcome to the Unit 6 District Assessment Review. Well, the first segment is going to be problems 1 through 4. There was 9 questions on the district assessment. Today you'll have the opportunity to look through problems 1 through 4, and then you'll have a second segment that will deal with problems 5 through 9. And here what we are going to do is we're going to do test corrections, and the test corrections are for half credit. And you would put your problem number, you'd rewrite the problem with the error that you made, identify your error. Why did you answer the way you did on your Illuminate test? And so you'll need to completely write the problem down, and you'll see from as we go through that the problems, such as problem number 1, has an X and a Y axis, so you'll need to build that. You'll need to put enough dashes that it goes up to positive 10, positive 10. This is not big enough, but yours will be bigger. And then you'll need to draw your figures as you see them in problem number 1. And as I go through and actually label out the points, and then you do the problem correctly in this column here. Let's get on to the test. Problem number 1 has 2 figures, and of those 2 figures, you need to look and analyze everything that you can before you try to answer there's 3 questions at the bottom, but you need to try to figure out everything that you might know on this. So let's locate where all these points are located. Point A is at -5, -2. Point B is at -2, -2. C is at -2, -8. And point D is at -5, -8. We also have an image here. This image is A prime is at 2, 5. B prime is at 2, 8. C prime is at 8, 8. And D prime is at 8, 5. We also need to look at the figures in terms of how long each side is so we can see if they're congruent or not. A to B, if I count -5 to -2, that's 3 units. From B to C, it goes from -2 to -8, that's 6 units. So it's a rectangle, this would be 3 and 6. Let's look at this one. From A to B here, goes from 5 to 8, so we have 3. And this one goes from 2 to 8, which is 6. So we have congruent rectangles. That's going to really help us to determine what type of transformation. And we know that there's, for congruent figures, they can do a translation. They can translate by sliding. They can reflect, and they can rotate. A lot of times we do a lot of reflecting. This thing could undergo a reflection, but at some point it looks like it's going to need to rotate. So let's take a look at the transformations that they indicate below. The first one, it says rectangle ABCD is rotated 90 degrees counterclockwise. Okay, well, counterclockwise is in this direction is counterclockwise. As opposed to clockwise, where you read the hours on a clock. So it's rotated 90 degrees about the origin. Well, we need to locate the origin, which is here. And then we need to do a rotation. Well, we have a nifty tool here that will allow us to look at what a 90-degree rotation actually is. I'm going to take and I'm going to put my compass right on the origin. Then I'm going to pull it down here. I'm going to try to get it to A here. There we go. I can pull this little pencil here. Keep rotating it until it gets to A. I slightly missed it. I'm going to pull it down. Pull it over a little bit. Okay. So now I'm ready. I have my point at the origin and I have another pencil point at A. I need to rotate it 90 degrees. Okay. It's hard to read how small that is, but we're going to rotate it approximately 90 degrees. It started at about 160, so we're going to go down to 60 here, and I'm going to move this out of the way, and I'm going to put my first point. That was A. This is going to be A prime, and then we're going to do it again with the origin. I'm going to move that, move this tool here. I'm going to pull it back just a little bit. Okay, I think we're ready. We're looking to rotate it 90 degrees, which is about right there. So let me get a different color here, help you out. So it looks like we have a dot here and a dot approximately there. This is going to be A went to here and B went to here. And then we do the same thing with these. Right here, we're going to make it much bigger. Bring it over here, try to hit D. Pull it back just a touch. Okay, now I'm going to rotate it about 90 degrees is about right there. Okay, and one last one to rotate 90 degrees. Pull this in so it's touching. 90 degrees is about there. That's 1/4 of the circle. And I'm going to put another dot. And I'm going to go ahead and I'm going to connect it. So I still have a rectangle, and now it's been moved. A went to here. B went to here, D went to here. I see a D up here, and then this one went up here, and I see a C prime up here. Now, it's still a congruent figure, but however, I haven't seen what happens. Somehow I need to get this figure to rise up. I wonder how many units I need to get it to rise up. The rest of this question says, followed by a translation 10 units up. So if I count, this is at -5 and A prime is at +5. Well, that's a difference of from here to here is 10 units. That means this guy here is also shifted 10 units. And the same as here, from there to there. And from there to there is 10 units. Looks like it's perfect, so we have a true statement there. So we're going to write true for number 1. I need to erase a little bit of this. Okay, now we're back to the original triangle. Problem 2. Rectangle ABCD is reflected across the x-axis. This is the x-axis. So we would have it, and it would go, it's 2 units there, 2 units here, so 2 units up, 2 units up. This is 8 units, so it needs to go up to 8. And this one's 8 away from there, 8. So we'd have a rectangle that looked just like this. And that would be A and B. Okay, next thing it says, then it translates 3 units up and followed by a reflection across the y-axis. Well, we're gonna move this whole thing up 3. And then we're going to reflect it over the y-axis Now the problem is the orientation of this rectangle under that reflection is not going to turn. We need to somehow turn this rectangle, you know, either clockwise or counter. This is clockwise, or you could turn it counterclockwise 270 degrees. That's not going to result in what we just looked at. Is not going to result in a congruent figure that's right on top of under a transformation. The last one, rectangle ABCD, is translated 10 units up and then reflected across the y-axis. Okay, well, we have the same problem here. We're going to take this triangle, and all we're going to do is move it up 10 units, and then we're going to reflect it this direction. Well, it's still going to be in this shape, right? If we reflect it, you're going to end up with a shape like that. That's not going to be and it's not going to drop straight on top of the image. So that's going to be false also. Problem 2. Problem 2 says the triangle shown on the grid below has vertices at A, -1, B, 3, 0, and C, -1, 3. The very first thing you're going to need to do is find those things. A corresponds to -1, 4. So this point right here is A. -1, 4. It goes on to say that this is point B, is at 3, 0. And this point is at C, -1, -3. So we have them labeled perfectly. And then it says, suppose that triangle A prime, B prime, C prime is the triangle that results. After you reflect this triangle about the x-axis. So we're going to reflect the triangle, and then we're going to translate it 2 units to the right. Let's just focus on point A, because that's all that they care about. Where does point A end up? Okay, well, the reflection is over the x-axis. So here's A. It's 4 units from the x-axis, so its mirror image is going to be here. So this is 4 units, and then it goes -4 on the reflection. And then it says it's translated 1, 1, 2 to the right. So here is your A prime. It's located at 1, -4. That's what they wanted you to do, is to put that point on your graph. I'll write it a little darker so you can see. A prime 1, -4, and it's located. You needed to put the dot in the right spot on your graph. When you do your test correction, please indicate where you put your dot on your mistake. Question 3. Figure ABCD undergoes a series of transformations that result in figure A prime, B prime, C prime, D prime, as shown below. Okay, well, we have an original. Now let's look at, we have this original figure is very, very small, and then the image is much larger. So the image is larger than the pre-image. And it asks us to complete the statements below by selecting the correct option from each drop-down menu. Okay. Before I always begin, I always like to locate all my points. A, B, C, and D in the tiny triangle is at -2, 3, -2, 3 for A. That's right here. B is at 0, 3. C is at 1, 1. And then D is at negative 3, 1. We have this other triangle, A prime is at 0, 6. B prime is at 4, 6. C prime is at 6, 2. And D prime is at negative 2 right here. And so what do we have here? The question is complete the statements below by selecting the correct option. Okay, we have, let's look at some distances. This is 4 units, and then we go from negative 2 to 6, that's 8 units. A to B is 2 units, and D to C is going to be 4. So it looks like a factor of 2. So then we look at the statement below, selecting the figures are not, our choices are they either congruent? They'd have to be the same size. Are they the same size? Yes or no? No. So if they have the same angles though formed, then they are similar. So we have similar figures, which means that in order for something to grow by they need a dilation factor. And we see that this one is twice as big. So we know that a dilation has occurred. Additionally, there's also a translation. It's cut off there, but you can see it on your Illuminate. Was performed. This figure, they're all in the corresponding location, so there's just a sliding that occurs. Now, on your corrections, you're going to need to write down the complete sentence, and whatever you put in the squares needs to be addressed. This is the final question on this section. Consider the two triangles shown on the grid below. We have a triangle 1 and triangle 2. We're going to do a little slightly change our approach to this one. Let's take a look. We know that these are actually right triangles, right? So instead of, we could look at the coordinates, which would be very helpful, but let's look at the length here. This triangle goes from 1 to 4. Well, that's 3 units. And from negative 1 to 5 is 4 units. Okay, well, it's a right triangle, so I know that a squared plus b squared equals c squared. Some of you might be ahead of me. It looks like a Pythagorean triple, which it is. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. And then c would be the square root equals 5. So this is a 3, 4, 5 Pythagorean triple. This, it goes from 2 to 8, that's 6 units. And jumps from 2 to 10, that's 8 units. Well, we can do it again, but it looks like, if I know my Pythagorean triples, it's a 6, 8, 10 triangle. A squared plus b squared equals c squared. 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. 100 equals c squared. Even mental math, I know that 10, it's got to be 10 times 10. But I'll take the square root of 100 equals the square root of c squared, so c equals 10. Now we can see that this triangle is related to that triangle by triangle 1 has a dilation factor of times 2. So triangle number 1 to number 2 is going to have a dilation factor times 2. It's important to name from what triangle we're going to the other triangle. Let's look at these questions. Triangle 1 is neither similar nor congruent to triangle number 2. Well, we know that that's not true. We have similar triangles. They have the angles of a constant dilation factor. So there's, on your test, it was to be left blank. So I'm just going to write false next to it. But you were supposed to just leave it blank. Now we get a little harder question. B, a 90-degree clockwise rotation about the origin. Here's the origin. And it's a clockwise, so it would go in this direction, 90 degrees. It's going to change the orientation of all of these. Followed by a translation of 1 along the y-axis. This is the y-axis here. But if you look at this point here, if it's rotated to 90 degrees, it's going to end up at 1, 1. And then a translation vertically of only 1 unit sorry about that. A 90-degree clockwise rotation about the origin followed by a translation of 1 along the y-axis and a dilation of 2 centered at the origin will map the triangle. So that is false. And C, a 90-degree clockwise rotation about the origin, then you're at 1, 1, and all of these has a dilation factor of 2 centered at the origin. That's true. So you're going to want to check mark there. There is no D. There's no sequence of transformations that will map triangle 1 exactly onto triangle number 2. That's all transformation. That's false. We know that we could do the rotation, we could do the dilation, it would be exactly mapped. Triangle number 1 is similar to triangle 2. We proved that already. That's true. And then finally, F, triangle 1 is congruent to triangle 2. We know that's false. They're not even the same size. So that concludes problems number 1 through 4. Problems 5 through 9 will be on the next video.